All right, we're getting closer to this big semester exam, and this is the fourth review sheet that I've given you to help you get prepared for next week. And this is covering the Chapter 9 topics, so let's just get right into it. This first problem is solving a right triangle, and we're given side A as 5, so we can go ahead and put that down. And we're given the hypotenuse, which is always labeled as C, as 13. And so it's our job to find side B, and we can use the Pythagorean theorem for that. So remember, just as a reminder, the Pythagorean theorem says C squared equals A squared plus B squared. And C is 13, so C squared is 169. A is 5, so A squared is 25. And we're solving for B squared. And we subtract 25, that's 144. And then we do the square root of both sides, and that gives us a B value of 12. So we found the side that we're looking for, the one side we're missing. And now let's find the rest of the angles. So it really doesn't matter where you start. I've got several options here. Since none of these are decimals, then they all can be used. I just want you to stay away from using a decimal measurement in your trig functions. So these are all good numbers, good solid numbers. So let's just say we wanted to find this angle A. I could do several things. I could do sine A. Sine is opposite over hypotenuse. I could do cosine A. Cosine is adjacent over hypotenuse. I could do tangent A. Tangent is opposite over adjacent. So really, you're not going to go wrong picking any one of those three. I'll just do sine angle A. So sine angle A is, in this particular case, it's the ratio of 5, which is the opposite side over the hypotenuse, 13. And anytime you're going to find an angle measurement, you're going to need to do inverse sine. So just think about how would you get A by itself. You would do the inverse of sine on both sides. And this is the only time that you're going to use this feature in your calculator, the second sine feature. So we'll go to our calculator at this time and do second sine. And you'll see the sign with a little -1 looking exponent, but that means the inverse of sine. And then put 5 divided by 13. And our instructions are to, let's see, the instructions are to round sides to the nearest tenth and angles to the nearest degree. So let's do it that way. So angles to the nearest degree. So 22.6 to the nearest degree, that would be 23 degrees. And now you can just use your truth that there's the sum of the angles in a right triangle, or any triangle for that matter, it's 180 degrees. So we found angle A, so let's just take 180 degrees, subtract off the 90 degree angle C, and then subtract our angle A measurement of 23 degrees. And that's going to give us the angle B measurement. And we'll go ahead and go to our calculator. So 180 minus 90 minus 23 is 67 degrees. So we got all the missing parts, and that's our finished answer for number 1. Okay, so this time on number 2, we're given an angle measurement. Angle A is 65 degrees, and we're given the side A is 16 units. And so now we got to find sides B and C and angle B. So let's just go ahead and do our angle B first. That'll be pretty simple, because once again we can just start with 180 degrees and subtract off the 90 degrees, subtract off the 65 degrees, and that gives us an angle B measurement of 25 degrees. right, so angle B is 25, and now let's work on finding one of these missing sides. So again, you got some choices here. You could use the, if you want to go ahead and put down the 25-degree angle down here for angle B, and you could look from this angle's perspective, and you've got the ratio of opposite over adjacent, which is tangent. So you could do tangent for the 25-degree angle. You could do the same thing up here, opposite over adjacent for the 65-degree angle. And that, in both cases, that would help you find side B. So it doesn't really matter which way you go. I think I'll just come down here to angle B, and I'm going to build the ratio of opposite over adjacent for angle B, and that's tangent. So tangent 25 degrees is opposite over adjacent. And to solve for B, I'm going to multiply by 16 on both sides. And that's just going to cancel out the denominator 16 on the right side of the equation. So all I do now is go to my calculator and do 16, 10, and then 25. And we're rounding these to the nearest tenth. So B is going to be approximately 7.5 units. All right, now we can stay down here with this if you like. We can do adjacent over hypotenuse, and if you remember, that's the cosine ratio. So let's just stay down here with cosine 25, and that's adjacent, which is 16, divided by hypotenuse, which is the side we're looking for. So this time, to solve for C, I'm going to multiply by C on both sides, C times cosine 25, and that'll cancel the C denominator on the right, and then I'll just divide by cosine 25 on both sides. So that's going to cancel these. So C is going to be approximately, just go to your calculator and do 16 divided by cosine 25 degrees. And that's 17.65, so rounded, we'll say it's 17.7. Okay, and that's our answer for number 2. Here's a little word problem. We're supposed to find the distance here from A to C. I just labeled this as X, that's what we're looking for. So this distance across the river, and we're to round to the nearest tenth. So let's look out from the angle that we're given, the 25-degree angle B, and in relation to that angle, we're looking for the opposite side given the adjacent side. So hopefully you're familiar with opposite over adjacent is tangent. So we're going to use the tangent function. Tangent for the 25-degree angle is the opposite side, which is what we're looking for, divided by the adjacent side, which is given. So once again, I'm going to multiply both sides of this by 50 in order to get my solution. So calculator time, 50 times tangent 25. And we're rounding to the nearest tenth. The decimal is 23.31. So that distance is 23.3 feet. All right, that's the answer for number 3. Number 4, another little word problem. We have this moving truck that has a ramp, and most of them have this. So let's just draw a little sketch here. So let's just say this is the truck itself where things are going to be loaded in. And coming out from the back is this ramp that we walk up to carry the items. Okay, so here's the ground, and so there's a right angle being formed right here, and we're told that the angle of elevation of the ramp, that just means from the ground to the ramp, coming up this way, elevating, that's 32 degrees. Okay, the ramp is 4 feet above the ground, so that side of our right triangle would be 4. So we're wanting to know what is the length of the ramp. So there's the side, actually it's going to be the hypotenuse of this right triangle. So once again, from the 32-degree angle, we look across and we're given the opposite side. We're trying to find the hypotenuse, and the ratio that is described as opposite over hypotenuse is sine. So we'll do sine of 32 degrees equals the opposite side over the hypotenuse. Multiply both sides by x. That will clear out that denominator. And now divide both sides by sine 32. And we'll go to our calculator and we'll do 4 divided by sine 32. And we'll do this one to the nearest tenth as well. That's approximately 7.5 feet. All right, very good. Let's go to number 5. So you're going to need to be able to change from radians, that's what number 5 is in, to degrees, and then vice versa. So the way we convert from radians to degrees is we multiply by this conversion factor, 180 degrees divided by pi, because we're trying to cancel pi, so just remember that pi should be represented as being diagonally across from each other. And normally you can do some reducing. I don't want you to give me a decimal or anything like that. Just you notice that 6 goes into both of these. 6 goes into itself, and then 6 goes into 180 degrees. It'd be 30 degrees. The pi's would cancel, so all that's left is to multiply 7 times 30 degrees, and that's 210 degrees. Okay, to go from degrees to radians, it's the flip of this. So we're going to multiply by pi over 180 degrees. Okay, and so let's see what goes into both of these. I think 20 goes into both. 380 divided by 20, I believe is 19. Yep, so I can change color here. 20 into 380 is 19, and 20 into 180 is 9. And so my reduced fraction form of this would be 19 pi over 9. Okay, number 7. The length of a circle, arc length of a circle made when the paddle wheel rotates 330 degrees. So there's a formula that we learned a few weeks ago to find the arc length of a circle, and the arc length is denoted here as this S, and the formula is arc length equals radius of the circle times theta, the angle that's represented, but this has to be in radians. Okay, so this formula will not work properly if theta is not given in radians. And in this problem, it's not. It's presented in degrees. So let's do the conversion of taking 330 degrees and do the conversion of pi over 180 degrees. And let's see what goes into both. I know that we could, let's see, 30, I believe. Yep, so 30 goes into 330 11 times, and 30 goes into 180 6 times. So that would be 11 pi over 6 radians. All right, so it's easy enough. We can find the arc length by taking the radius, which is given as 14 feet, and multiplying by our theta value, theta measurement in radians. And this will be rounded to the nearest tenth. So in your calculator, you're just going to do 14 times 11 times pi. And that gets divided by 6. And to the nearest tenth, it's about 80.6 feet. So you should know the formula to find the arc length of a circle. Okay, for these, we are supposed to sketch these angles and then find the reference angles. That's what the directions were. I didn't get those directions copy them over from your review sheet, but that's the way they were read. So let me just sketch out negative 110 degrees first. So we'll do a little XY plane. So remember, if we're doing a negative measurement, we're going this direction. So this would be negative 90, this would be negative 180. So to do negative 110, I'm going to go to negative 90 and then just a little bit more, not very far. I'm going to let that represent the extra negative 20 degrees. Okay, so that's negative 110, and then in green, I'm going to show the reference angle. Reference angles are always made between the x-axis, which is here, and the terminal side of an angle. Reference angles are always between 0 and 90 degrees, okay? So the mistake a lot of people make is they try to make reference angles between the terminal side and the y-axis. They're never made with the y-axis. They're always made with the x. All right, so I went an extra 20 degrees to make 110. So if you think about it, there's 90 degrees here in this third quadrant. So I've already gone 20 of those degrees, so that means there's 70 degrees left. So the reference angle is 70 degrees. Okay, now let's do one in radians. So the rule of thumb is if you're given radians for these problems, I want you to stay in radians. So this is positive, so let's just identify these quadrantal angles. So this is pi over 2, this is pi, 3 pi over 2, 0, and then 2 pi. Okay, so we're supposed to go 2/3 of the way over to pi, 2/3 pi. So I'm going to approximate that, and it's about right there. It might be a little, it's pretty close. So I'm going to call that, I missed the origin a little bit, but I'm going to call that 2 pi over 3. So the reference angle, again, is made between the terminal side of that angle and the x-axis. So this green double bar represents the reference angle. And if you're given radians, then keep your reference angle in radians. So I went 2/3 of the way to pi. That means there's a third left. So pi over 3 would be the reference angle. All right, very good. Okay, so we've got a couple of these problems where we're given the terminal side of theta passing through a point. So let's just do a little sketch. And we'll plot 6, -2. I'm just going to say 6, -2 is right there. And there's my terminal side going through 6, -2. I'm going to drop a vertical line down so I can form a right triangle. So this side would be 6 because I went right 6. This side would be 2 because I went down 2. And so I got to find the hypotenuse. So again, c squared equals one leg squared plus the other leg squared. C squared is 36 plus 4, which is 40. C is the square root of 40. So in simplified radical form, that would be 2 times the square root of 10. Okay, so if you're wondering where did that come from, I used the square root of 4 times the square root of 10, and I simplified the square root of 4. Okay, so 2 root 10 is the hypotenuse. Here's theta. You always put, on these problems, you always put theta close to the origin. And now we can run through our 6 trig functions of theta. So we'll start with sine. Sine is opposite over hypotenuse. Okay, so opposite over hypotenuse. The 2's would cancel. So it's like 1 over the square root of 10. And then you always rationalize the denominator. So you're going to multiply by root 10 on the top and the bottom. So that's going to be root 10 over 10. So there's your value for sine. The only thing you have to worry about with sine, and I got to slow down just a little bit, remember that you're in quadrant 4. And in quadrant 4, the x-coordinate is positive and the y-coordinate is negative. The x-coordinate always relates to cosine and the y-coordinate always relates to sine. So in quadrant 4, sine is negative. So don't forget, sometimes it's easy to come up with the ratios and then forget about which quadrant you're actually in, and that's going to affect the sign of your answer. Okay, so now let's go to cosine theta, and that's going to be 6 over 2 root 10, which is 3 over root 10. And then when we rationalize multiplying by root 10 top and bottom, it's 3 root 10 over 10. And cosine is positive in quadrant 4, so that remains positive. Okay, tangent theta is opposite over adjacent, 2 over 6, which reduces to 1/3, but tangent, remember, is sine divided by cosine. That's a negative divided by a positive, so tangent's also going to be negative in quadrant 4. And so now all we have to do is flip these over to get the reciprocals. So the reciprocal of cosine is secant. And it's easier to work with this. Just think of 1 over the square root of 10 and flip it over. And of course, if sine is negative, then so is secant. So that's just going to be negative root 10 over 1, which is negative root 10. The reciprocal of sine is cosecant. Cosine is secant. So once again, you could just take your cosine value 3 over root 10 and then just flip it over, and it's root 10 over 3. And the reciprocal of tangent is cotangent. And just take negative 1/3, flip it over, and you get negative 3. Okay, so that's our final answer for number 10. Let's move on to number 11. So same type of problem, we just have a different point. So negative 3, negative 4, I'm going to say that's here in quadrant 3. Drop a vertical to make a right triangle, put theta next to the origin. This side would be 3, this side would be 4. You do the Pythagorean theorem, c squared equals 9 plus 16, c squared equals 25, so that means the hypotenuse is going to be 5. Okay, so let's run through the 6 trig functions of theta. Sine theta is opposite over hypotenuse, but in quadrant 3, sine is negative, so that's negative 4/5. Cosine theta is adjacent over hypotenuse. Cosine is also negative in quadrant 3, so that's negative 3/5. Tangent is opposite over adjacent. So opposite over adjacent, and tangent is positive in quadrant 3 because it's a negative divided by negative, so that would be 4/3. And then just run through your reciprocals. So for sine, that's cosecant. And that's just going to be negative 4/5 flipped over. So that's negative 5/4. Cosine is secant. Same thing, that would be negative 5/3. And for tangent, that's cotangent, and that would be 3/4. And there's your answer for number 11. Okay, so for these 12 through 15, you're going to need unit circle knowledge, and I've just put a couple of unit circles here. I'll just use this top one for these top two problems, and then we'll work on these. So you really need to be familiar with the unit circle for this exam. So cosine 270, remember cosine is x when you're looking at these unit or these ordered pairs on the unit circle. Cosine corresponds to the x coordinate and sine corresponds to the y. So all we really have to do is find the 270-degree angle, and it's looking for cosine of that, and that's the x coordinate of that. So here's 270 degrees. The ordered pair that corresponds to that is 0, -1. The x coordinate is 0. That's what cosine corresponds to. So my answer for number 12 is very simply just 0. Okay, so for the next one, this is sine -150. So the way the unit circle is laid out, it's going in a positive direction, but it's easy enough to use going the other way too. We just have to sketch out -150. So that's -90 plus another 60. And that puts me right there at it says 210 degrees, but that's the same ordered pair that I'm going to be using for -150. Okay, so the ordered pair is right here. Sine relates to the y coordinate, and so all I have to do is grab that y coordinate, and that is my answer. The answer is -1/2. Okay, very good. So let's do cotangent 3 pi over 4. So here's 3 pi over 4. Well, tangent is y over x. We're more familiar with tangent. Well, cotangent then would just be x over y. Okay, so take the ordered pair for 3 pi over 4, and the x coordinate is -√2 over 2. The y coordinate is +√2 over 2. So you can probably see that your final answer is just going to be -1. Okay, so for secant -7 pi over 3, it might be helpful to change this into a mixed number. That's -2 1/3 pi. Okay, so let's think about what that would look like. We start here and go negative. So -2 pi is all the way around. That's a complete circle. And then we'll do another third of the way around, and that puts us right there. Okay, it says 300 degrees, but it's the same as, we're going to use the same ordered pair that we would use for -2 1/3 pi. Okay, so we've identified the ordered pair. Cosine and secant are reciprocals of each other. Remember, cosine corresponds to the x coordinate, which is 1/2. So if cosine is 1/2, that means secant must be 2, because all I have to do is take cosine and flip it over, do the reciprocal, and I'll have secant. So 2 is the answer for number 15. All right, so number 16 is a graph, and we're supposed to determine the period. The period is the horizontal length of a cycle. Okay, so let's see if we can determine what this pattern is and how often it repeats. So it looks like it goes up, down, up a little, down, and then you can probably tell at this point that pattern just keeps repeating itself. Okay, so the horizontal length of a pattern is really what a period is, and it looks like the length of that horizontally is 4 units. So my answer for number 16 is 4. Amplitude and period. The amplitude is the absolute value of the number that's in front of your trig function. So the amplitude in this case is going to be 6. The period for sine is you take 360 degrees, and then you divide by whatever's in front of theta, which is 2. So the period is going to be 180 degrees. So we have an amplitude of 6 and a period of 180. All right, got a couple of graphs, and that's going to wrap up this video. So the graph of cosine, first of all, we're supposed to identify the amplitude. So once again, amplitude is 2. The period, we do the same for sine and cosine. We do 360 divided by 360 degrees divided by whatever's in front of theta, and that's understood to be 1. So the period's going to be 360. And the theta intercepts for cosine, that's 1/4 of the period, 1/4 times the period, and 3/4 times the period. Okay, so 1/4 of 360 is 90, and 3/4 times 360 is 270. So we can go ahead and plot those. We know we're going to be crossing 90, 270, so it looks like we're going to be crossing every other tick mark. I'll go ahead and put in my amplitude of 2, positive 2, negative 2, and we're ready to sketch. So cosine will come up, and we're going to go down to 90 degrees. We're going to bottom out at 180. So we're going to basically the point 180 negative 2 is where we hit the bottom, and then we come back up to 270. And we'll complete a cycle, and it's just going to keep on going. We completed one cycle by the time we got to here. The period is 360, so you can tell we started here, we ended here, and that took 360 degrees to do. So that's the graph for number 18. And we'll do a sine graph. So amplitude in this case is 1. That's the number in front of sine. The period is 360 degrees divided by 2 in this case. So that's 180 degrees. And for sine, this should say theta intercepts. For sine, that's 0, half the period, and the period. All right, so for us, that's going to be 0, 90, that's half the period, and 180. Okay, so sine's going to cross here, here, and erase the 1. Okay, and I should have kept going. I'd like for you to show all the way to 360. As a matter of fact, I think I'm going to do that. So let me change this up a little bit. I'll do it the way I want you to do it. So you always start off, these are what we call the quadrantal angles if you make your way around the unit circle. Those 4 stops along the way. Well, the fact that there's a 2 here means that I'm actually going to make these in groups of 2. So instead of just 1 tick mark to get to 90, I'm going to have 2. So here's a group of 2, here's another group of 2, another group of 2, another group of 2. Okay, so I'm actually going to go through this pattern, the sine pattern, 2 times by the time I get to 360. That's really all that means. Okay, so here's, let's put our amplitude in, so 1 and negative 1. So here we go with sine. It goes through the origin. It's going to top out at, this is 45 degrees, and then we're going to come back down through 90, because we said 90 degrees is at theta intercept. We will bottom out at negative 1, and then we'll come back up to 180. So there's one of those patterns we were talking about. So now I should be going through this again before I get to 360, and that will complete the graph. So top out at 1, come down to 270, bottom out there up to 360. And then that just keeps on going forever and ever, but you don't have to continue on. Just as all I want you to do is show me through 360 degrees, and that will be sufficient. Okay, I think we're done. I think we got them all. So hopefully this helps you with the Chapter 9 portion of your semester exam preparation. So let me know if there's anything I can do to help you.